Hello, our project title is Measuring Recoil Force on High Calibre Gun. Our first presenter is Nurul Afiqah binti Umar Azhar. Next is Nur Syahira binti Azman. The third presenter is Numan Zakirah binti Mazama Nasir. Next is Aina Laila binti Haji Ismail. And lastly, Nur Rashidah binti Fakrul Razi. Enjoy!
Hi, Assalamualaikum warahmatullahi wabarakatuh. First of all, the objective. The objective of this project is to measure the recoil force in a high caliber gun. The nature of the recoil process is determined by the force of the expanding gases in the barrel upon the gun, recoil force. Therefore, to acquire accurate recoil force, the pressure of expanding gases must be calculated. This rearward impulse can be substantial, but it is only applied for the length of time that the projectile remains in the firearm barrel. There's two types of recoil during the shooting of a high-caliber gun. First, primary recoil. Primary recoil happens when firing pin hits the bullet. Propellant creates an expansion of gas that overcomes the inertia of the bullet and accelerates it down the barrel against friction force and air resistance. Next is secondary recoil. Secondary recoil happens when the bullet leaves the barrel and there is a sudden release in gas. The gun is pushed back much like a rocket.
So next, we'll proceed with the type of transducer used. So in this project, to measure recoil force on a high caliber gun, strain gauge is used. As you can see, the characteristics of the strain gauge is it is a primary transducer, passive transducer, and analog. The specifications of the strain gauge used. Firstly, for this project, geometry of the strain gauge used is linear strain gauge, have one measuring grid, and measure the strain in one direction. The strain gauge used is in Y series. The connections use integrated solder tabs that allow direct soldering on the strain gauge. The temperature response adaptation for the high caliber gun use is austenitic steel. The active grid length is short measuring grids of 3 mm or 6 mm. Next, the range or the electrical resistance is from 120 to 350 ohm, which is low ohm strain gauge. And lastly, the sensitivity of the austenitic metal is from 2.0 to 12 gauge factor.
Okay, so now we proceed with the working principle of strain gauge. A strain gauge is a device used to measure the strain of an object. In order to be practical, a strain gauge must be crude, which is bonded onto a larger specimen that is capable of withstanding an applied force stress. Kat sini maksud dia strain gauge tu kita akan dekatkan dia dekat bahagian specimen yang boleh tahan force applied. The gauge is attached to the object by a sealable adhesive gum yang khas. As the object is deformed, the foil will also deform, causing its electrical resistance to change. Tensile deformation, which is stretching, will increase the electrical resistance by simultaneously increasing the length and decreasing the cross-sectional area. The change in resistance will imbalance the bridge circuit, causing a voltage which is the V out, voltage out, proportional to the amount of applied pressure. So the strain gauge ni, it works to convert an applied pressure into a measurable voltage signal that will amplify and convert it into a loop current signal that will measured by using certain bridge. So the resistance change for this strain gauge is commonly measured using a Wheatstone bridge. The most common type of strain gauge consists of an insulating flexible backing which supports a metallic foil pattern. Okay, so where the strain gauge is attached? Dekat bahagian gun kita tu, dekat mana kita letak kita punya strain gauge ni kan? Since the pressure trace connector is so small, so we place the strain gauge on the side of the barrel. The strain gauge is glued to the barrel at about the midpoint of the casing. The grey block to the left is a depth of JB weld. It prevents the shooter from accidentally yanking the wires of the strain gauge. So waktu shooter tu shoot, dia takkan terlanggar mana-mana wire that is connecting to the strain gauge to measure the force applied.
Assalamualaikum. I'll be explaining about Wheatstone bridge circuit today. Okay, there's three types of circuit. There's quarter bridge, half bridge, and full bridge. We choose full bridge because it's the most sensitive. You also need to know the type of strain measured, which is bending strain. Bending strain happens when the force acts perpendicular to the area, like this. Okay, the configuration of the circuit, there's 4 active strain gauges, 1, 2, 3, and 4, and 2 of them are rotated 90 degrees, which is R3 and R4. Okay. Some of the characteristics of this circuit is R1 measures the tensile strain, R2 measures the compressive strain, R3 measures the tensile Poisson effect, and R4 measures the compressive Poisson effect. Okay. The reasoning why we choose a full bridge Wheatstone circuit is because bending strain is measured independently. The temperature effects are also well compensated as it gets really hot in the gun barrel. There is also high output signal and excellent common remote rejection, and a full bridge circuit also compensates the Poisson effect.
So I will continue to explain about the diaphragm inside the strain gauge. Okay, basically kita tahu yang strain gauge ni work based on the applied force either by tension or compression. So the conductors will deform. So kita tahulah bila ada perubahan dalam length dan cross-sectional area, akan ada perubahan pada electrical resistance inside the conductor also. So, for example, bila length tu meningkat and the cross-sectional area decrease, so the resistance will increase. So, itu kenalah dengan apa explanation dia kata the electrical resistance of any conductor is proportional to the ratio of length over cross-section area. So I'll move to the explanation of the materials of the diaphragm. Okay, kita tahu usually the classic strain gauge is usually made of the metal sebabkan dia punya good spring characteristics. So tetapi kita tahu yang metal ni bila kita constantly strain dia over the constantly repeating cycles of straining over time, metal ni akan achieve dia punya fatigue limit. So apa-apa material pun sebenarnya so bila dia achieve dia punya fatigue limit dia, dia akan ada flow berlaku kat situ. So bila ada flow berlaku dekat situ, dia akan disrupt the performance of the instrument. So bila dia disrupt the performance instrument, so akan ada berlaku error lah dekat reading of the instrument itself. So dalam modern manufacturing ni, instead of diorang using diorang using metal, silicon digunakan untuk constrain the construction of strain itself. So kenapa kita guna silicon? Okay, rather than metal, bila kita achieve dia punya fatigue limit, akan ada flow, so dia akan disrupt the performance of instruments. Berbeza dengan silicon. Silicon ni bila dia reach dia punya overstress, dia dah overstress, dia akan completely fail. So tak akan ada error dekat situ bila dia completely fail. So dia tak akan baca lah apa-apa. The reading lagi accurate lah, performance lagi bagus daripada kita using material metal dalam strain gauge ni. Okay, next slide. Okay, this is the working principles of a diaphragm. Basically sama je strain gauge tu. Okay, kita boleh tengok kat sini kita tengok diagram ni. So sini adalah strain gauge, sini adalah diaphragm yang macam berombak ni kan. So kat bawah ni adalah tempat kita apply pressure lah. So kat sini adalah bridge. Okay, sama juga konsep dia. Strain gauge ni akan stretch kepada certain length bila ada applied pressure. So akan ada perubahan dekat resistance reading tu. So resistance reading punya perubahan ni akan menyebabkan imbalance dekat bridge circuit ni yang membolehkan ada bacaan reading voltage kat sini bila ada applied pressure. Okay, next slide. Okay, this is another design of the diaphragm. So this is what we call as metal isolating diaphragm. So kita tengok dekat sini, instead of macam previous slide ni, kat sini macam tak ada apa kan. So just a normal strain gauge and the diaphragm, and kita ada tempat applied pressure and bridge. Tapi dekat sini still the applied pressure ada. Instead of ada, instead of using only strain gauge and diaphragm, dekat single silicon wafer ni, ke atas ni, silicon diaphragm ni, they act as both. They act as a diaphragm and strain gauge untuk dia exhibit the mechanical properties untuk capai low fatigue and high linearity. So kita tengok kat sini ada fluid kan. Okay. Kalau nak tahu, tapi silikon ni sebenarnya dia tak compatible untuk kebanyakan many process fluids. So pressure ni dia akan transfer dekat silicon diaphragm ataupun sensor using a non-reactive field fluid lah. So basically fluid ni adalah basically on silicon base atau fluorocarbon based liquid. So isolating diaphragm ni dia design untuk lagi to be more less rigid compared to the silicon diaphragm. So the purpose tu adalah sama juga untuk transfer pressure kepada proses fluid kepada field fluid tu. So dia tak act as a spring element. Okay, silicon sensor ni experience sama juga same pressure, so dia takkan directly expose to the process fluid tanpa ada contact kepada process fluid ni. So we can conclude that the metal isolating diaphragm ni experience less stress than the silicon sensing diaphragm. So they avoid the problem of metal fatigue experienced by the transmitter designs using metal as the sensing spring element. Okay, we move to the next slide. So this is an illustration of the diaphragm inside a gun. So we could see both the image ni. Satu gun ni without diaphragm and satu lagi adalah diaphragm. Okay, kat sini kita tengoklah macam biasa ada soft lead bullets tapi without diaphragm and ada bursting charge. Okay, and the image dekat sebelah kanan ni pula, there is a diaphragm, sheet iron diaphragm separating all the bullets from bursting charge. And compared to using soft lead bullets, they guna hard lead antimony bullets. So dekat sini, ini dekat area dia load, diaphragm ni dekat area yang dia load bullet tu dia letak. So that's all from me. Thank you for listening to our explanation of the strain gauge for the recoil force.